Welcome everyone to another OCP Tap call. This is call number 145. It's a pleasure to welcome Dr. Yudan Yi, co-founder and chief technology officer of GEODNET, to today's OCP Tap call. GEODNET, for short for Global Earth Observation Decentralized Network, is a groundbreaking blockchain-powered GNSS RTK network that has redefined what's possible in large-scale crowdsourced positioning infrastructure. Since its debut at 2021 ION GNSS Plus conference, where it earned the Best Presentation Award, GEODNET has grown into the world's largest continuous operating reference station, CORS, network, with more than 20,000 stations deployed across 150 countries and 5,000 cities. Each GEODNET node is a high-performance, triple-frequency GNSS receiver operating with a decentralized ecosystem where individuals contribute infrastructure and were awarded through the GEOD token system. This model has enabled massive global reach and density, unlocking centimeter-level accuracy for applications in ADAS, smartphone, robotics, and IoT devices. Today's Dr. Yi share insight into GEODNET's architecture, growth, technical performance, as well as its expansion into aircrafts and drone tracking, and upcoming support for the Zona LEO system network. Dr. Yi brings over 2 decades of expertise in satellite, geodesy, and precision positioning, with a career spanning TOPCon positioning systems, Quanshun C, and Siena. He holds a PhD in satellite geodesy from the Ohio State University and a Bachelor of Science in Geomatic from One University. Please join me in welcoming Dr. Yuan Yi as he presents GEODNET, a decentralized global GNSS network for the future of precision positioning.
Okay, yeah, thanks for the introduction. Yeah, it's a long introduction.
Welcome.
Yeah, okay, my talk is try to talk a little bit about our project GEOD network. So we have been working on this project for about 3 years, and we have a lot of progress, and I want to report it here. Yeah. Okay, here's a short agenda. So first, I will start a brief introduction of GPS RTK technology, and then introduce GEODNET, and do some kind of network performance matrix analysis, and also introduce real-world network usage performance. And at the end, I will introduce kind of like through our project. Yeah, RTK technology is, I think, pretty old technology. So the idea comes from about 40 years ago, it's 1980s. So it's used the differential technology to cancel and reduce common error sources for the satellite navigation systems. So mainly cancel the satellite orbit, satellite clock, ionosphere, troposphere, and you can see there's a kind of diagram to show the early days RTK, how it works. So the RTK commercialized in about the 1990s, started with a base and a lower pair. We normally call the 1+1 base and lower. So at the early days, they use the UHF to transmit the data from the base to the lower, and the lower do all this kind of RTK algorithm to get the centimeter position accuracy. So you can see in early days, the base and the lower pairs to limit the RTK usage. So then about the 2000, and the RTK network infrastructure is began to build, and try to broadcast the RTK base station connections use the internet. Early days, mainly the government and the private segment, for example, Trimble, TOPCon, NRCAN, they build their network and they provide the service. The build the network is very expensive, For example, in the United States, we have all these DOT networks. All the states, they have about 100 stations in each state, and spends a lot of money. So in early days, because the infrastructure is so expensive, so the Trimble and other companies introduced we call the VRS technology or network RTK technology, try to still get the centimeters accuracy, but which are sparse RTK networks. So the RTK networks, in order to get better performance, normally we try to limit the based on lower distance within about 20 to 30 kilometers range. Recently, we have a lot of progress in this GNSS technology. So the transition from the dual constellation GPS plus GLONASS systems and also dual band L1, L2 system to multi constellations. We have Galileo, we have Betel, we have in Asia, we have the QGNSS and also Indian systems. And also we get the new signals L5, E5, L6. And also in the last 10 or 20 years, the GNSS modules became cheaper and cheaper. So in all this, all this kind of GNSS hardware is very expensive. But now these days, it's not expensive anymore. So this will try to get kind of a trend to do a global density RTK networks infrastructure to achieve centimeters position accuracy in seconds and also globally. So actually, this is something we try to do. Okay, as I mentioned earlier, yeah, this idea come from ION GNSS conference about a few years ago, so 2021. So we get basically paper presentation. So the founder, Mike Horton, do the presentation, and it's very welcomed. Yeah. So let me basically introduce the GEODNET mining baskets. So it's pretty simple. Get a base station, do the installation, and connect to the internet. On the base station, send the data to the server, and then the host get the tokens. So the basket is very simple. Up to there, we have about deploy more than 20,000 stations, mostly in Europe. And we have about 40,000 in United States and the other area, for example, Asia, South America. Yeah, we have a lot of interest in these days. So we expand Brazil very quickly. Yeah. All our base station is support all the constellations, all the frequency, and also we calibrate by the NGS, and all the base stations is monitored by the NRCAN PP RTK service. So here is a short summary of the milestones during the last few years of our development. So currently, we have about 100 enterprise customers, and we have about 4 million revenue. And the stations you can see from the 2021 to the current days, we increase a lot. And we have customer across automotive, agriculture, and drones, and also we have the Web3 customers. This is the kind of our coverage map. So basically, you can go to the website to see the coverage map real time. So if a new station come in, the coverage map will update very quickly. Here list all the GEODNET usage in the last 6 months. So we can see almost all the continentals except the Atlantic will have usage in last 6 months. We have about the 50K individual device connected and the 10K daily average users. And we support all kinds of GNSS receivers, include the high-end geodetic receivers and also the cell phones. As I mentioned, so all our stations is monitored by the NRCAN PP article service. So we partnership with NRCAN to do daily monitoring of all the stations. If the station is not good, we will kick out of our article service. Yeah. This is the short video to show how the our GEODNET service. Can you guys hear the voice?
No, there's no voice from the.
Oh, okay. Yeah. So we have the robots, we have the drones, we have mowers. Yeah, sorry, they should have a voice.
Check when you're sharing your screen. There's often a separate checkbox you have to check to add audio. Otherwise, by default, it's video only. So you may have to reshare, but just look for that option.
Okay, yeah, anyway, maybe we can do the next one. Oh,
Like the share button in the middle. If you click, you probably can also choose voice.
share button in the middle.
That's okay. I think worst case you can explain what we see.
Okay, let me how to skip to the next one. Okay, yeah, here shows all this article service. Actually, we did a lot of analysis and talked to a lot of article customs. So we summarized the article lower requirements. So a lot of kind of application changes a lot. For example, survey, agriculture, the mobile phones, automotive, IoT, drones, robots. The applications and the environments changes a lot. So one key thing is the coverage is very important. So on all these kind of article consumers, they often have a dual band, which lower grade antennas. So normally L1, L2, or L1, L5. As current these days, it's major L1, L5 receivers for this consumer device. And for the device like automotive and mobile phones, it's mainly in clear sky. Yeah. For the RTK precision location issue is commonly for most of the customers. They concern a lot. So our conclusion is the dense network, which is short baselines globally and simple to use, which modelize signals, is the key to solve the RTK performance to support all these kind of different RTK customers. For all our stations, so basically we did a kind of QC quality control of all our stations. So we monitor the station coordinate. We use real-time RTK PP partnership with NRCAN, and also for each hour we do these statistics to count all this number of epochs compared to the expected epochs, and also we count on the latency of the data packages, and also we check all these RTK load measurements, which are about the cycle sleeps and the multipaths, and so all the multipaths metrics is come from the TQC. It's a very kind of famous QC software in GNSS community. So we calculate the MP multipaths L1, L2, L1, L5, and also the which the E5 and outbox. All the QC data metrics we can access from our API, from our database. So we do request a kind of sign non-disclosure agreements. So here is the whole network, hourly epoch availability in the last 3 months. So you can see the median epoch availability is 99.9 something, and even we have the stations increase, we still keep the similar performance. So here is a summary of the metrics during the last half a year. So the latency, the median is 0.47 seconds. So the requirements for the customer is normally 1 second. The cycle sleep is more than 10,000 observations per cycle sleeps. So the industrial standard is about 300. The multipath is 0.23 meters. The standard published by the NGS is 0.5 meters. The standard from the IGS is 0.3 meters. So we have very decent network performance of all the stations. This is the usage of the GEOD mapping during April and June, about 3 months. So we totaled about 4,000 hours. And the average RTK fix rate is about 98%. So we have very decent RTK fix for these GEOD applications. I think it's very easy to understand because GEOD is always flying high and it's clear sky. So the RTK fix is very reliable and quickly. So the GEOD people case is DJI GEOD. It's very popular. Yeah, as I mentioned, it's very clear sky conditions, and also use the triple band GNSS receivers. This is the example analysis of the agriculture usage. So we in the United States, you see there's a lot of cases usage in April and June. Actually, in spring, agriculture is very busy. So we have more than 24,000 hours during this from April to June. And the average RTK fixed integer rate is 98.6%. The device agriculture used typically is FJ auto steering systems. It also uses the triple band GNSS receivers, and as we all know, it's also very clear sky conditions. So we also have some kind of automotive usage case. So we have more than 188,000 hours for the automotive use cases. So the average RTK fix is about 6-7%. Consider the kind of the complex environments, because all the customer can be in the urban area under the tree. I think the RTK fix that this number is pretty decent. So the typical use of of the automotive usage is a dual band L1 and L5 GNSS receivers. It uses a small antenna, and it's non-professional setup, just put it under the dashboard. Yeah, we also have work with Solana RTK seeker forms. So this is the form with the L1, L5 dual band GNSS chips. So we did in some tests, the static test. You can see we can achieve centimeters accuracy with GEODNET RTK, and also for the driven test, we can get a decent RTK fix in kind of open sky area. Yeah, and also we partnership with Zonla. So Zonla is, I'm not sure you guys know it, but it's a new LEO PNT systems. So we have about 1,000 stations can track Zonla signals. So Zonla have X1 and X5 two signals, and they plan to launch about 300 satellites. Currently, there's one live satellite now, and you can see we give an example of Zonla signal L1, X1 and X5 signal tracking from one of our stations. So Zonla signals is much stronger signals because it's LEO satellites, and they can potentially improve the indoor and the harsh environment navigation performance. Yeah. If you guys want to check the RTK, so we provide free RTK trials. So you can go to the website, you can apply an account and do some tests. And if you want to host the stations, you can also go to our website, purchase a station, and host the stations. Yeah, and then you can get some tokens. Yeah. Yeah, if you guys want to know more things, yeah, welcome to contact us. So we have Twitter, we have emails. Yeah. Yeah, I think that's all. Any questions?
Hi there. I have one question. Is there a maximum limit on how fast a user terminal could be going? Like, would this work on airplanes, or are cars kind of the limit?
You mentioned the article usage. I think the common is kind of driving cars. I think maybe small airplanes. Yeah, I see some use cases for the small airplanes, but I don't know. People for the big airplanes go very fast. I didn't see any usage for these big airplanes, but small airplanes, we have some customers use our service.
There's some questions in the chat.
Oh, okay.
I can just read them out for the recording. Do you make data available to academics for free?
We are not specific for the academic for free, but we do have some professors talk to us and say, okay, they want to which area, which stations. We just give them download the data, them offline the data to them. Yeah, but we didn't make it some kind of policy. Yeah. So if you guys want to check which area, which stations, which day, and you feel free to contact me. Yeah,
a second question. Do you have any setups or providers that offer the data that are using multi-antenna GNSS receivers to do things like beamforming and integrity checks? Also, do you have systems or algos in place yet to monitor for potential jamming or spoofing? For example, truck drivers or cabs?
Actually, we don't do this one, but we have custom do this kind of multi-GNSS antenna, do this kind of integration. Yeah. And also for the jamming stuff, we don't do that, but our customer will do that. Yeah. Did I answer your question?
Yes. That's a question from David LaRiviere.
Yeah,
I
I can put my email in the chat box, and if you guys want to talk to me, send me an email. Yeah, and if you guys want to some kind of data for academic usage, yeah, feel free to talk to me. Normally we will accommodate. Yeah, it's not a big issue. Yeah, but we do require people's kind of sign the non-disclosure agreements, because we don't want people random make some kind of noise, you know.
Greatly appreciated. The context for one of my questions is there are a few critical systems that rely on GNSS. One of the more common ones is telco, but the one I'm particularly concerned with are financial data centers, where we want to packet stamp all our events to within a few nanoseconds, or ideally even sub 1 nanosecond if the gear ever allows it. But the problem is many of these data centers are located next to federal highways. And for various reasons, there may or may not be motivations for some people, for example, who are only allowed to drive so many hours a day, or they need to follow the speed limit. They're being monitored by a GNSS. And so they may have motivation to get jammers and then not realizing they're driving by a data center that processes an enormous amount of money. And so if there was a way to ever build a monitoring system where in real time we could identify this and then just essentially stop people from doing this, at least on these critical paths, it'd be a great public good. That was the basis for my questions and interest.
Yes, thanks for the question. Actually, we realized from our network, we realized a lot of station in some kind of sensitive area, they have jammers. So for example, in Middle East, some of our stations sometimes get jammed, and some kind of random location, if they're nearby, they have some kind of metal base, they get jammed very easily. Yeah, we do have this kind of data, but we didn't do a lot of analysis in this direction. Yeah.
If you're interested in partnering on that, I have potential students. We could look at this. I've had students building just sort of one-off Raspberry Pis that are very similar to what you have, where we get some of these dual receiver GNSS, like a U-Block CBKF9T, and they build essentially data warehouses to pull the data. But we only have a few receivers. You have this at scale, so it's very exciting. I just posted a link to the chat. This is sort of a derivative of that. So here they're actually using ADS-B, which are the protocol where airplanes broadcast their call sign and GPS coordinates if they have GPS. And so there's a series of receivers around the globe that gather this data, and they use this for a proxy for GPS health. And so you can see exactly what you were just describing. In the Middle East, historically, this has been quite bad. I'm actually surprised. It's the first time I recall seeing around Israel where it's only yellow, not red. But if you look anywhere near Ukraine and now pretty much the entire border between NATO and the Russian Federation, you see a lot of red dots.
I see.
And it's pretty much continuously like this. But it would be great to try to look at even potentially fusing these sources together I love what you're doing, which is collecting the raw GNSS data. One of the advantages of also using ADS-B is sometimes you can pick up airplanes that are hundreds of miles away and use them as a giant real-time distributed GNSS health system as well. So it could be an interesting avenue to pursue.
Yeah, I'm not sure you you are aware of a project called WinBase?
No, please describe.
Yeah, there's a project called WinBase. So actually, we partnership with WinBase to deploy ADS-B tracking device. So the device can track ADS-B, the airplanes, and also can track all the GNSS satellites. So basically, it's a dual mining project.
Great. And I apologize. I joined the chat or joined the video presentation, I think about 4 or 5 minutes late. But did you cover when I went to the main website, there's this whole aspect related to, it looks like GNSS based, I'm guessing some sort of crypto mining as a reward function?
I didn't cover that one. Yeah, my background is mainly on the RTK GNSS background, so I didn't cover all this kind of Web3 aspect. Yeah.
Okay, I'd love to follow up with people from your team on this. I also teach financial engineering, so it's curious. But I was just curious, do you know at a high level, do they reward miners based on the quality of their receiver setup? For example, if they, one, have multiple antennas, two, multiple frequencies, if they've gone through like a survey mode or the actual mode of the GPS receiver. And then also just in terms of the granularity of the data, for example. Yeah, someone else has mentioned helium, which was the first time I remember sort of coming across this idea of sort of using GNSS and I guess location disparity or scarcity as a resource as opposed to hash rates in computation.
Yeah, we do give rewards based on the, so first based on the installations. So the installation is good, then we will get given more tokens. If the installation is bad, then we will give less tokens. So how to justify the installation is good or bad? So we check all these multipaths come from the data. And also we will set the minimum of the sequence tracking and the GPS constellation tracking. So we didn't tracking L1, L2, L5 signals, and we didn't track GPS, GLONASS, Galileo, and Beidou. So this is all for major constellations. Well, one thing is I'm not sure you guys realize it's because all the hardwares used in GEODNET is manufactured from our partnership. So basically, we are not allow random device coming into our network.
Gotcha.
So basically, we have a device certification procedure. Yeah.
Okay, I'll follow up offline, but I'd love to discuss with you more. I really like what you're doing. It's something I've hoped to do, sort of laying some of the groundwork, but you already have a lot of the infrastructure. So there may be additional use cases for this that could be very valuable to society and protect some very sensitive systems. So I'd love to chat more about that.
Yeah, sure. Yeah, we can communicate by emails offline. Yeah.
Perfect. Thank you so much. Yeah, I really like this presentation. It's very interesting. I keep hearing more and more about using the various correction services. Do you also get any of the, I know they're for, especially for like survey, there's ways to post-process the data you got to get even better results for everything. Do you apply anything like that, or is it all primarily real time?
So basically, we look all the stations, all the data. So we do kind of provide the people to download the log data. So then they can convert to the LALAX and do the post-process. So we do have a called PPK service, but currently we didn't charge any money. So, but we do request accounts to download the data. And we also have an API. So if customers, for example, they want to build a system based on the our logged data, you can call the APIs to download the data directly. Yeah.
And so just to be clear there, are you also offering a post-processing service similar to like some states do and other governments?
We do have people ask for it, but we are not doing the exactly things. Currently, I recommend people just use NRCAN or OOPS, but you know the OOPS law is offline. The government shutdown. Yeah.
Gotcha. Okay. Yeah, it's still a very, very interesting presentation. I really like this.
Yeah. Thank you.
And I'm just curious, what do you see as potentially next steps or next either product developments, enhancements, algorithmic changes?
Yeah, actually, that's a very good question. Actually, even we have about 20,000 stations, we still see some gaps. For example, even in the United States, we are not cover all the highways. So our next phase in the at least in the United States, we will try to cover all the major highways.
Excellent. Have you talked at all yet to any of the telco carriers to see if you could get their GNSS data? I was actually thinking the same thing recently, again, for trying to monitor, especially the highways.
No. Yeah, maybe there's some direction for us to try to reach. Yeah, currently we are not. Yeah.
Because they may have the statistics. It depends on how much they're relying on GNSS, or do they have PDP, or do they have a combination. But there may be a version of reality where they have a data warehouse with all of this, and then firms like yours and academics, we could take this and then derive additional value, whether it's, for measuring things like spoofing, trying to get better post-processing for surveying, even in some cases, weather and atmospheric modeling. I mean, there's a lot of interest in this now. It's pretty neat. If you guys haven't looked at it, I just became aware of this recently. NVIDIA now has this entire framework for doing digital twins, specifically targeting the radio frequency space. So I just got back last week from the NVIDIA GTC event in Washington, D.C., and they had vendors like Nokia, Keysight, and others, and they're looking at this for like 5G and 6G, but it's also directly applicable to GNSS signals and things like, can you model the 3D geometry of where someone is to figure out what is overwhelmingly likely a multipath reflection? And so I have this problem actually in my lab. I'm right in downtown Chicago, and half the satellites being used, even though I have one of the multiband receivers, are actually multipath reflections off high rises across the highway. And so this drives me nuts. I'm looking at algorithms now to filter it, but it could be a more broader problem as well. Can we better simulate this and even do this in real time?
I see. Yeah, let's know that. Thank you.
Yeah, if you want, I could send you links on it. But essentially, I think what they're doing is like physics modeling, and then also taking advantage of things like ray tracing. But they're talking about getting to the granularity of like, can you in real time adapt your cell phone signal where it knows a truck is about to drive between you and the antenna, for example, or even going another step eventually and using this for sensing. So detecting if people are walking through buildings, or if you get tight enough granularity, even people using it to interact with computers, which gets a little creepy, but they can see through walls. So, but a lot of really exciting stuff that is in this area. So I absolutely love what you're doing.
I see. Yeah, thank you.
All right. And hopefully you will send me the slides so I can put them alongside the recording on the wiki.
Sure.
Perfect. Yeah, and as well, I'll follow up offline. I have several groups of students, teams of 4, that have agreed they want to do GNSS related projects. We're right at the point of doing precise project selection details. So there may be ways we can collaborate. Everything my students do is open source and just in the public domain. So if companies want to use it, it's fair game. But it could be a great way to get them real world experience. So I'd love to chat more about that offline.
Yeah, sure. Thank you. Okay, that's all.
Perfect. Okay. If there's no more questions, we can adjourn actually quicker.
Finishing early for once. And Ahmed, thank you for arranging this as always. I love these.
You're very welcome. And all right, so thank you again, Yudan, for the very informative presentation. And looking forward to seeing everyone in 2 weeks by a presentation from Daniel Aman, which is here actually, about GNSS fraud detection with community-owned RTK network. All right.
Very interesting.
Bye.
Right.
Have a great week, everyone.
Bye-bye.
Bye-bye.